I should bring my hard hat out, pretty much. I'm going to talk about how you look for oil and gas. And we already talked about the geologic process to a degree that we need the crock pot, time, temperature, pressure, and we need the source material. We're going to talk a bit about this fundamental idea of a conventional resource and an unconventional resource. I personally like being unconventional. It's just kind of who I am. But here it has different meaning, which is conventional means you can get it out of the ground without working very hard. Unconventional means you've got to stimulate the rock because the resource is in a layer of rock where there's plenty of pore space to hold the resource, but the permeability stinks, meaning you can't flow. So you've got to stimulate the rock or you've got to dig the rock, one of those things, to get more. So it's interesting, by the time we get to geothermal, like you're going to have a great geothermal lecture, and I used to give it, and we had conventional geothermal. Now that we're doing geothermal, we don't call it unconventional, we call it enhanced. How's that? Enhanced geothermal. So tools we're going to talk about, and then we're going to talk about the land part, which I really like because the US is very unusual that we, as I told you before, a lot of people can own the subsurface in the US. In almost every other country in the world, only governments get to own the subsurface. It's complicated. So in oil and gas, or looking for lithium brine, which I'm involved with companies that are doing that, or looking for geothermal, you do exploring, based on what you find, you do permitting and leasing, you do drilling, you do completing of the wells, you do production, and then you do processing and refining, which Diana's going to talk about, and she's a wizard on that. And so in today's lecture, we're going to talk about this stuff. So oil and natural gas rocks. So when I came to Stanford, and Tony Stainer, who's in the class, and I were at Stanford Business School, they had a class called Decision Sciences. And the nickname for decision science class was Dome, No Dome. Do you have a dome or not? And a dome is an anticline. And an anticline is where you were most likely going to have a trap. See a dome here? And there's the oil on top. And actually, if you have gas in there too, the gas would be on the top because it's less dense. So you'd have that dome of rock, that fold, and in it would be gas and oil and water underneath it, okay? Kind of like when you're making, has anybody ever made salad dressing yourself? I used to do that when I was a kid. And, there'd be those layers based on the density. So it's a little more complicated than the dome, no dome idea. Remember, there's sedimentary, they're not igneous, and they are not metamorphic. You're not going to go to Yosemite and find oil, okay? And the two key words about a reservoir, and now we care about reservoirs for geothermal, we care about reservoirs for lithium brines, and if you go into, and brines are super old, a couple 100-million-year-old water that's down in the subsurface, but it has a lot of chemistry in it, and some of that chemistry is kind of sexy for battery stuff. So we have a big new interest in that we didn't have 5 years ago. So, but in order to get it out of the ground, you got to worry about the porosity, which is what's the volume in the rock, and what's the permeability, which is the ability to flow. And this is a piece of trivia. There's a really great guy named Mike Ming who was a TA of this class with me 45 years ago, but I'm only 39. And Mike does a little video for anybody who wants to get really nerdy on what Darcy's Law is. And Darcy's Law is about how you get permeability and how things flow through rocks. It's totally up to you whether you want to give yourself the bonus points of watching Mike's little video. Okay? Anatomy. So, oil and gas, this is in a dome situation, conventional oil and gas. You don't need a dome for unconventional. So this is a trap. So otherwise, a conventional reservoir is porous and permeable. And so the oil and gas can just flow and flow and flow till it hits a barrier, okay? And that barrier is a trap. And we have different kinds of traps that we're going to talk about in a moment. So that's the geology, the petroleum geology I learned before we realized we could be enhanced or unconventional. That was like a big breakthrough. So you have a cap rock or a trap, you have a reservoir rock, and you have the source rock, and the source rock has that dead algae in it, in the case of oil. Okay, so here, are a bunch of traps for conventional reservoirs. On the left is the anticline, otherwise known as dome. You can have a fault. So if you have a fault, because of the movement on the faults most of the time are a barrier, but sometimes they can have leakage up to somewhere else. It's very interesting. And then in the Gulf Coast, we have big salt domes that pierce sedimentary rocks. And the salt dome itself is very impermeable. And so on the flanks of that salt dome, the oil goes da, 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 and then it goes up and is trapped against it. All of this we can see on seismic data, which is like an MRI or a CAT scan for the Earth. And again, making this analogy that and we're going to show it in a moment, that when I got my master's degree at Stanford, our ability to see the Earth was like an X-ray. And you guys don't even know what an X-ray is because they're so primitive compared to MRIs and CAT scans. Now, like our radiology, but radiology for the human body and radiology for the Earth have paralleled each other exactly. Okay? And when you think about it, it's all about computers. So reservoir rocks are like a rigid sponge. That is really true. And so these are combinations of having low porosity and impermeable. That's not very good at all. So that's a barrier. You have medium porosity, impermeable. That's an unconventional or needs to be enhanced situation. And then you can have a conventional or high porosity, high permeability situation. So, obviously, so what we did as explorers and utilizers of things, we found the easy stuff. That was the conventional stuff, okay? And then we kept going and we've gone on to the unconventional stuff. And now, and we just kind of keep reworking this. There's not a lot of new discoveries in North America. There are some globally, but they're getting started in those places requires cooperation with some complex governments. So unconventional comes in many different flavors. So you see conventionals over on the left. We have a lateral wellbore. Here we got with hydraulic fracturing over here for a shale. We have tight sand, so those are sands that are, when you say tight sand, it means it has porosity, but it has really poor permeability. We have coal bed methane, you see it up at the top. So in the San Juan Basin of Colorado and New Mexico, there's a very large coal bed methane play. Involved the Ute and Paiute tribes too, which has made it really interesting. I worked on that when I was at ARCO. So, and then, we have words for unconventional oil can be oil that's like tar. So the tar sands up in Athabasca in Western Canada, that's heavy oil. It gets called, I think one of the problems about oil and gas, one of the many problems about oil and gas is we have a bunch of inconsistent names for a bunch of things, which I'll share some of those with you. So you got conventional and enhanced or unconventional for both. And so you're not in charge of memorizing this. It's more for you're like, oh my God, how complicated can they make it that you have like a cue sheet where you're like, okay, let me see if I can tag this. But the main thing, and the last category is not commercial at all, but it's something that scares the bejesus out of me, which is we have a lot of methane that is trapped in frozen ice. And so as ice is melting in our poles, we're releasing a lot of methane. And in Japan, they are trying to explore methane hydrates, which is methane in a frozen form, and try and extract that because, as many of you know, Japan doesn't have much native energy resource. They import almost everything. So they try harder than some countries do to explore some unconventional sources. But when you think of oil and gas, we have a slide, again, I don't know whether it's coming here in the next slide, which I apologize for. We can dice it even more than this. Okay, this is really great for me. So if you're a geologist and you go to a road cut, which is what that is like a med student getting a cadaver. You're like, yeah, we get to see what's going on inside the earth. Look at those layers of rock. Okay, because most of the time you're walking around on the earth and you can't see what's underneath. You can shoot seismic lines, you can drill wells, but those are lines and dots, right? When you get a road cut, you're very, very excited because you get to see what's going on. Beyond what you get to see like at Mesa Verde or the Grand Canyon or all those wonderful places in the Four Corners where there's a lot of exposed geology. So the reason I put that there is kind of keep playing with the medical analogy. So oil and gas development can't happen anywhere. This is showing areas that have been closed off for development. Then it shows you where the basins are in the pink colors of where most of our development of oil and gas shale basins has taken place. And this is a list, like geology, the way the oil and gas got deposited, they don't know where a national park is, right? That just happened 20 or 100 or 300 million years ago. So you put all these layers over things, and you say, okay, what can I not do? And then what's left, right? So I built a company called MAP, and part of it is learning to use lots of geospatial information and put all these layers on, and then try and eliminate anything that's controversial and just get to the places where it would be okay to develop wind or gas or whatever it would be. But you have to ask, these are just beginning some of the questions, right? And for those of you, I like to use the social license to operate as the willingness of a community to let you in. The social contract to operate is the willingness for a community to let you stay in, because as a developer of oil and gas or anything else, you got to behave well. You got to be a good citizen in the community. These are tools. Any industry has a toolbox. So here it's showing you a thumper truck, which is in the early days of geophysics, they would dig holes in the ground, then they would drop explosives in the hole, and then they would run away and they would hit a button and there would be like boom. Because basically with geophysics, you want to send sound waves into the earth and then have geophones that listen to see how the sound comes back up. And that's how you get your X-ray or MRI of the earth. Instead, we've gotten a little less invasive than dropping explosives into holes in the earth, and we use these thumper trucks to thump and send signals down and then listen as they come back up. So this is a bunch of the things that we use. As I say, geology and geophysics are a lot like internal medicine and radiology. So geologists are generalist doctors, and geophysics are like radiologists. We're trying to put that, and we work closely together to understand what's going on. So two other tools we use is we use maps. We use maps that other people created to get us oriented and to say, well, yeah, I'd go here rather than there to get started. And then one of the things we use when we are, for instance, drilling a well is we collect cuttings that come up as the well is being drilled, and we lay them out very carefully and try and map them to what depth they came up from. And then we have paleontologists who study those rock cuttings, for instance, and you look for fossils, because paleontologists, because of evolution over time, there are shells and fossils of living things that only existed for a very narrow period of time, and so we can age date things, and we can match, and we can say, oh, because we found that fossil, that rock ties to that rock, because we're trying to understand the subsurface when we have very little information. So this is a little bit more on the seismic part. This idea that you have the thumper truck, you have geophones, and we can do the same thing in the ocean. It's a little more complicated. You tow behind these floater things with thumper signals dropping down into the ocean, and then geophones behind that are listening for the signals to come back, because it has to go through the water, down to the ground underneath the seafloor, and can measure and develop an MRI of the earth, essentially. It just has to be tuned. So that's the kind of geophysical data I had up at the right in 1980. And now that's 3D visualization. Now you actually can get in, you can climb into something that's like a little helicopter, or it's a virtual reality where I can essentially pretend I'm an oil molecule and I'm inside the rock. It's amazing. Super cool. If you had told me that 40 years ago, I would have laughed at you. This shows you that, so because wells are a point, but they can go down 10, 20, 30,000 feet, usually 8,000 feet. Schlumberger and companies like that maybe you've heard of, Baker Hughes, they're really good at the geophysical tools that we use, that we drop down a wellbore and we collect, and then we pull them up and we measure all kinds of information. So you see at the top all those different pieces of information, and when you drill, even if you don't find what you're looking for, you want to collect a lot of data, because that data can be useful to you or others in the future. So one of the, having data analytic tools that we didn't have when I first started, we didn't have any of this, but now we can use all this geospatial data and organize it and plot it and see trends and help us decide where to go. Very, very helpful. Okay, land rights. So I was just in New York City all week, as I was telling you, and I remember my grandmother lived in Midtown Manhattan, and like 40 years ago, it was really upsetting when the AT&T building was built because it blocked her view. So in New York, they have air rights. It's a big deal, right? So we have air rights, we have surface rights, we have mineral rights, we have water rights, we have so there's the air rights, right? That's in honor of Manhattan and other cities where that's a big deal, and people pay prices and negotiate over those things. So the mineral rights is where I want to spend most of my time, and in general in the United States, mineral rights control everything in the subsurface except water. So gold, silver, coal, oil, gas, etc., lithium, carbon management, even the ability to inject carbon dioxide permanently in the subsurface, you have to have control of the mineral rights, because that pore space in the aquifer, someone has to have the right to that, because Microsoft or Frontier will pay you to inject down into that. So who gets that, right? Is part of the story. So in the United States, we have 4 kinds of land ownership: private, federal, state, and tribal. And there's the surface rights and the mineral rights. And the mineral rights can be leased. And so the lessee would be like Shell, and the lessor would be me if I was the landowner. So I can get a royalty from, if I lease my mineral rights to Shell, They are going to sign a lease with me to give me today. When I first got into this business, it was like an 1/8 royalty. And today it's more like a 1/4 royalty. And you have no if you're the royalty interest owner, you have no environmental liability, and you get a share of the gross revenues of production, but you have rented your subsurface to an extraction company who's going to produce a resource, and you get money off the top. So it's a pretty interesting arrangement, but it applies to oil and gas, it applies to lithium brine, all those other things I talked about, and a similar, and we'll get to this later when we talk about renewables, if this mimics, if you go for wind development, you get an easement on the surface rights, and the landowner can sign, instead of a lease, they sign a wind easement. In exchange for that, they get paid up front for that, and then you can earn a royalty in the wind production, which is what we did. We incubated about 1/3 of the wind in the country, and we had a royalty on the wind projects we developed. But I'm going to stick to oil and gas and subsurface, but I just want you to know whatever's going on the surface of if you want to develop anything, you have to go to those agencies and cut a deal to be able to do anything on the surface or the subsurface. Outside the US, there's one type of mineral rights, it's the government, and you usually you go to the government, you try and get a concession. So there's a guy named Armand Hammer who created Occidental Petroleum. He went to Libya a long time ago. So I want to look for oil. They said, great, drill a bunch of water wells for us. Then we'll give you a concession for oil development for a big chunk of Libya. And it turns out there was a lot of oil there, and that's how Occidental Petroleum was formed. So just for the fun of it, I'll go back to this idea of the social license to operate as a starting point. Big thing that our country has not done well, and I'm really interested in, is how you build trust in local communities. And I spent a lot of time in rural communities and gyms and churches and places like that, talking to people where we wanted to be able to develop a wind project. So that is, no matter whether it's oil, gas, wind, solar, whatever it is, you have to build trust with local communities, often rural places, and it's hard. And you need to override something called NIMBY, not in my backyard, and banana, which is even more extreme, which is build absolutely nothing anywhere near anything. That's a really good thing to bring home to your parents, right, or your friends. I learned a new acronym today, right? And so there's a profession, so the geologists and the geophysicists are the internist and the radiologist when it comes to the earth and resource extraction. But not much happens unless you get the landman, and that a landman is a man or a woman or he, she, they, it's any of those. But that role, kind of like a fireman has a role, the landman does all these things. And there's some people that specialize more in they're lawyers, essentially land attorneys. They're super involved in, deep documentation, because if you find something big, everybody wants to know whether you truly have the right to it. It's very contractual, right? Or does it belong to your neighbor? Or does it belong to grandma? So that's the big part is over on the left-hand side, which is documents and negotiation. And then the right-hand side tends to be people who are really good at listening and talking to people and figuring stuff out, building support, listening to the local regulators. How do you get the permits? How do you get stuff done? And not trying to shock and awe communities and go too fast, but to really build enduring partnerships. So this, it's not like you grow up someday and you say, oh my God, I really want to grow up and be a landman. But I kind of want to say, this is a really important area out here for any stewardship of any resource development, is to work in this arena. Some of you are like, I was kind of confused by Jane's lecture. Is it about what do I want to do when I grow up? Or she's pitching me on being a landman or working on resource law or some of these things. But this is we could have the coolest technology in the world, but if you cannot persuade communities that it's in their interest and economically share and have good stakeholder engagement around the whole thing, we're not going to get anywhere at all. In China, they have a different solution. No offense to anybody who's from China. I used to teach a class called China Energy Systems. There, the government decides, they have eminent domain, and they get it done. They build transmission lines, they build out infrastructure, they build out bullet trains. They are, an incredible force when it comes to decarbonization, because they just do stuff. And the government steps in. They build the Three Gorges Dam. They do those kinds of things. We're less set up to do that in our country, and we're very dependent on people who are good at this. So it's a very interesting and undersold career path, I think. So regulation's important. We actually have a ton of it. We're pretty good. Yes, there's been a little rearrangement of the chairs recently and removing a bunch of people from the Department of Energy and the EPA and places like that. But again, different philosophies about what's needed. Part of the reason that Donald Trump has been able to radically halt, like throw the parking brake on wind, and I will be back for the wind lecture, is you have to get an FAA permit for a wind farm. You do not need one for a solar farm. Solar's on the ground, wind is above ground. So these are all agencies that can be involved at a high level in terms of development, and these are the kinds of things we're regulating, okay? Really important things to regulate, and these are not, I haven't listed all of them, but doing things well and thinking about all these impacts is really, really important. And then these are examples of the kinds of, like City of Palo Alto. If you want to do anything in Palo Alto, there's a whole giant regulatory process there, and we tend to all gripe about it. Like even if I want to do something at my house, put in a fire pit, it's like a big, but it's important to me that things get done right. And I think culturally we all need to embrace that, but we also need to have really smart people going into careers in regulatory agencies who are intelligent like all of you and who really believe in stewardship at the state, municipal, or federal level. So these are just examples of many agencies. They all play important roles. And the more interdisciplinary their education, and so we have a program like the Schultz Fellows program here at Stanford that's designed for you to be able to go work in government for a summer. And it can be everything from the City of Palo Alto's utility to working at the California Utility Commission or something like that. And even if that's not your long-term path, to spend a summer understanding the importance of regulation and government stewardship and initiatives, I personally believe is really important. We have the Schneider Fellows program that allows you to work in sustainable energy at places like EDF, WRI, NRDC, places like that, that are working with industry and government. They're the NGOs that are trying to help make sure we make good stewardship decisions, not just around fossil fuels, but around everything else that we're doing. So this is reminding you oil and gas development on federal lands. It's showing you where our federal lands are, mainly in the West, and shows 13% of US oil production is on federal lands and 9% of total gas production. So it's significant. It's not the majority. And it's both more complicated in some ways to develop on federal land, and the royalty rate's lower, which is something the government should be charging more on those lands. And developing geothermal, a lot of the geothermal development is on federal land as well. This is just highlighting, if you have to be, remember I'm only 39, but I'm actually older, and this has been a hockey puck, is something, so the older people in the room are going to be familiar with the idea of something called ANWR. So Prudhoe Bay, you can see, is very close, and it was, for a long time, it was the largest oil field in the United States. That's not the case. And there's been a lot of tension. If you have a Democratic president, then ANWR is supported. If you don't have a Democratic president, then everyone says, let's drill in ANWR. And it's supposed to be, ANWR stands for, it's supposed to be a wilderness area. So it's just bringing that to your attention. It's showing how Alaska crude has declined from when Prudhoe Bay was a big deal. So some of you are aware of the fact that we don't have an even playing field for fossil fuels and other sources of energy. But that's a big topic. So for instance, we have something called the Price-Anderson Act that the government insures every nuclear power plant in our country. Did you guys know that? They don't insure any solar plants. The government does not insure any geothermal plants, but we insure our nuclear power plants. Guess why? Because our government does not own those nuclear power plants. It's owned by private, shareholder entities. And you could not build the nuclear power plant unless the federal government was the insurer of last resort because they're viewed as too risky. So that's a form of subsidy, right? So I'm going to get off. There's just all kinds of ways we subsidize different energy resources. We tend to subsidize renewables the least. On the oil and gas side, this is a whole list of tax incentives that we've had over time, and they're pretty permanent. And so they don't come up for conversation. Congress doesn't have to decide them. When I was developing wind, here we are, we're hustling along, trying to develop wind because there is an innovation wave. We have changes in technology, changes in policy, changes in markets. People really want wind. But there was a federal production tax credit, and guess how long it lasted? 1 year, 2 years. If it was a good period, 3 years, and then there'd be a gap. We never knew whether it was going to be there or not. So the whole industry was like, Oil and gas, you don't have to worry about that. It's always there. There are big subsidies. Now, one of the biggest motivations to have subsidies for domestic oil is if we don't spend the money on the subsidies for domestic oil, until we come up with a better way to move ourselves around, we have to spend that money going to war in the Middle East, which was what was going on when I was at Stanford. And so there's kind of this interesting intellectual argument. Do you want to spend the money on ships and bombs and tankers and going to defend access to oil in the Middle East, or do you want to subsidize development of domestic oil? So that's how we got to where we are, is the idea that we have that trade-off because there was not a belief that we had an alternative to using oil and gas to move ourselves around. So here we are. So you get, look at, I mean, how many industries do you have where you get 100% bonus depreciation? So when you drill a well, much of the cost of drilling the well is just like, oh, we get to depreciate it, yay. Okay, there aren't a lot of industries. You don't get to do that with a solar farm. So we could get into all of the details of this, but it is a very, we have something called stripper wells, which is not wells that take their clothes off. It just means they're very marginal wells, and we subsidize those wells and reward people to keep a well that is only producing 8 or 10 barrels a day because we're just worried that, you know, we don't have enough. There's that mentality of scarcity. So another way we subsidize oil is more indirectly, which is we don't put a price on carbon. So that's compared to other choices. So there's the direct subsidies and there's kind of the indirect subsidies. Talked a bit about geologic processes in the beginning, about how we need the crock pot. We made a distinction between conventional, natural production where you do not need to enhance it, right, with stimulation of the rock to make permeability. I kind of gave you an overview of the tools that we use, the radiology of the earth and other paleontological tools and things like that. Then kind of did a flyby on land and regulation. And with that, I'm going to take a bow.
If you want to learn more about this topic or other energy topics, visit our Stanford Understand Energy Learning Hub for free resources, including signing up for our monthly Energy Spotlight. Don't forget to subscribe to our YouTube channel and tap the notification bell to be notified for our newest content.